Hello, my Calc 3 student. Today we sorry, you're not Calc 3, you Calc 2. Today we talk about trigonometrical substitution in section 8.4. We're looking what kind of integral we can solving use trigonometrical substitution and what kind of substitution. Okay, let's go three possible situations. See, three possible situations. One is you have square root a square minus u square. Second, you have inside integral square root a square plus u square. And last one, you have inside integral u square minus a square. For this kind of situation, whereas a is some constant and u is some function, you can use trigonometrical substitution and solving your integral like trigonometrical integral. Doing each example separately. First one, let's go inside your integral. You have a square minus u square, square root. Here we use substitution. Let's go, u is a sine theta. Plug here, we have a square minus a square sine square theta. Take out a, 1 minus sine square. Oops. Sine. I don't know what happened. I'll try. Use trigonometric identity. You have, this is equal a cosine theta. This means we moving from root to this kind of function. Okay, great. What happened if you have second type? If you have sum inside root, this means your constant plus square your function. Then we use substitution, u equal a tangent theta. Tangent theta. Plug here, you have a square plus a square tangent square theta. Take out a, 1 plus tangent square. How you remember this is secant square, and this means here you have a secant theta. And last situation, whereas you have square root u square minus a square. Here we use substitution, u equal a secant theta. Plugging here, you have a square secant square theta minus a square. Take out a, it will be secant square theta minus 1. How you remember this is tangent square. This means here you have a tangent theta. Great. Now see some example when we can solving, and I think it's make our situation is more clear. Let's go, we have integral dx over x square square root 9 minus x square. First we need classified what kind of substitution we use. Looking for root, you have constant minus function. Constant minus function is example number 1, formula number 1. This is substitution will be use sine. This means here a square is 9, this means a is 3, and this means x is 3 sine theta. Here we need found derivative, dx differential. It will be 3 cosine theta d theta. Oops. Use this fact, we plug in, and we have first we have 3 cosine theta d theta. Here x squared give us 9 sine square theta. Root we have 3 cosine theta. This is, we can cancel it, and we have 1/9 integral 1 over sine square. It will be cosecant square theta d theta. As we know, it will be minus cotangent theta. This means here we have minus 1/9 cotangent theta plus c. Great, but question, we need go to back with our old variable, because this is new variable help us solving problem, but we need solving problem is the depend x. Okay, great. Here we need to remember what does we have. X equal 3 sine theta. This means sine theta equal x over 3. If you write right triangle, and one is angle is theta, because sine theta is x over 3, this means opposite side is x and hypotenuse is 3. Our answer have cotangent theta. We need found cotangent theta in our triangle. This means we need found other side is will be 9 minus x squared, and our answer, we go back, it will be minus 1/9 square root from 9 minus x squared over x plus c. Now we solving our problems. This is our answer. This means use trigonometrical substitution. You have 3 steps. First, classify what kind of type of integral you have and what kind of substitution you can use. Second step, solving trigonometrical integral. And last one, don't go back for your old variable. This is work if you have identified integral. If you have defined integral, you count in new border, and third step, it's only counting what you have. Doing one more example, this is from your book, is number 14. We have integral 9x cubed over square root 1 plus x squared dx. Inside square root we have 1 plus x squared. This means situation number 2 when you have substitution is tangent. Because a is 1, mean you have x equal tangent theta dx will be secant square theta d theta. Okay, now we're ready for plugging. What you have here? Oh, this 9, I can take it out of my integral. X cubed, it means I have tangent cube theta. Then I have dx, this means I have secant square theta d theta. Divide by, I have root, this means 1 plus tangent square, secant square, it will be secant. Okay. Now we little bit simplify, square and secant cancelled, and I have integral where I have tangent cube and secant. Remember how we're solving trigonometrical integral this type? This means we separate tangent square and tangent. Okay. Yeah, doing each step, it's more practice for trigonometrical integral. Secant theta, tangent theta, d theta. You see, I'm only rewrite my tangent cube. Now, what we're doing? We have this is 1 is all derivative from secant. This means looks like I use secant theta equal, for example, t, then secant theta, tangent theta, d theta, it will be dt, and use trigonometrical identity tangent square is secant square minus 1, we have 9 integral t square minus 1 dt. Okay, what we have here? We have 9 times c cube over 3 minus c plus c. We'll go back with secant, is no problem here. And now I have 3 secant cube theta minus 9 secant theta plus c. But I need go my back with my back variable. You remember we have substitution x equal tangent theta. This means what kind of triangle we have here? We have right triangle. You always work with right triangle. This is angle theta. Let's go. And tangent theta equal x. This means here will be x. This will be 1. And about the hypotenuse. Hypotenuse is some squares. And take it square root. Great. What is secant here? Hypotenuse over adjoint. It's mean about over 1. Let's go. Here we have 3 times square root 1 plus x square cube minus 9 times square root 1 plus x square and plus c. This is our final answer. Okay, great. Doing a couple of more. Okay. Okay. For example, number 32. What I did this example because it looks a little bit different. It looks like you don't have any square here, but you can use same method. Inside root here you have 1 minus x. Okay. What happened if I'm a little bit rewrite? Pretend x equal t square. This means dx equal 2t dt. And this means I have my integral now is square root 1 minus t square. Square root of t squared will be t. Dx will be 2t dt. T is cancelled. And bingo, we have integral type of when you can solving. We have integral square root 1 minus t square, maybe 2 we go out, and this is half dt. Now it's ready for trigonometrical substitution. This is first type of integral. This means t equal sine theta, dt equal cosine theta d theta. Plug in here, you have twice integral 1 minus sine square cosine square. Take it root, it will be cosine theta. Or remember, when I'm looking for all three possible situations, I write what happened if it take it a root. Okay, and here we have cosine d theta. This means we have integral, whereas you have twice integral cosine square theta d theta. Trigonometrical integral with even power for your trigonometrical function. Use trigonometrical identity. 1 plus cosine 2 theta over 2 d theta. No, I think with this 2 and this 2 we can cancel it. And now we can rewrite 1 give us theta, cosine 2 theta give us 1/2 sine 2 theta plus c. Okay, go back. You remember your substitution? Triangle theta, and we have t equals sine theta. T equals sine theta. This means here you have t and hypotenuse is 1. Okay, great. But I need sine 2 theta. Maybe I'm a little bit more work with my. Oh, first theta will be arcsine t. I can do it anything more. But for second term, I can rewrite 1/2 2 sine theta cosine theta. That's 2 and 1/2 plus c. Okay, this means I can rewrite my answer sine. Oh, first time write arcsine c, arcsine c. Then sine theta will be t. Cosine theta will be, here we have 1 minus t square. This means square root from 1 minus t square plus c. And now our final answer. You see how many substitutions we use for solving this integral. It will be t equal, because x equal t squared, this means t equal square root of x. Okay, here we have arc sine square root of x plus square root of x times 1 minus x and plus c. This is our final answer. You see how difficult integral we count, because we have some very complicated answer, but we can do it. This means no problem. Okay, great. Doing one more example is example number 34. And this what I take in this example, because here you don't have any roots, but we can use same method. See what we have here. We have x cubed plus x plus 1 over x fourth plus 2x squared plus 1 dx. Further, I little bit simplify my integral and see what I have here. Okay. First denominator, it will be x squared plus 1 square. Then I'm separate x. I work with first two terms. It will be x squared plus 1. Great, this means I can simplify something. And the last one, I'm rewrite only x squared plus 1 square. Okay. Dx. Oops. Here is whole. And this one is cancelled. And this means I have one fraction. It will be one integral. Or maybe I'm write this blue one is separate. X squared plus 1 dx. I think here we don't need any trigonometrical substitution. We can do it very simple because you can use u substitution here is x squared plus 1. Let's go, it's u. 2x dx, it will be du. And here you have 1/2 du over u, give you 1/2 natural log u, 1/2 natural log. X squared plus 1 is always positive. This means I don't need any absolute value. Great. You see, we're solving without any trigonometrical substitution. What about second one? We have integral. Okay. Oops. 1 over x squared plus 1, and this is square. Okay. 1 over x squared plus 1 and the square dx. Here I think we can try trigonometrical substitution and see what we have. Because you have sum to function, this means function plus constant, we can use substitution. X equal tangent theta, dx will be secant square theta d theta, and we have here it will be, we know x tangent square plus 1 is secant square. This means here denominator will be secant fourth power theta, but numerical it will be secant square theta d theta. Okay, simplify. This means square go out. This is, you have only second part. Remember what a secant is. You have, this means you have cosine square, because 1 over secant square it will be cosine square theta d theta. Okay, let's go. We have integral from cosine square. Let's mean 1/2 1 plus cosine 2 theta d theta, and take it 1/2. It's out of my integral. It will be 1/2. Here we have theta plus 1/2 sine 2 theta. Doing trick what we did before. This means sine 2 theta is separate, and I have 1/2 theta plus 1/2 times 1/2 times 2. I'm specially separate this way, but you can cancel it. And here we have sine theta, cosine theta. Okay, now we need to remember what we have here. We have substitution, x equal tangent theta. Great. This means this is theta, this is x, this is 1, this is square root 1 plus x squared. Okay, sine. Okay, final answer our integral. You remember we have, what else we have? Blue one, 1/2 natural logarithm. Because we separate for some these two integrals. 1/2 natural logarithm x squared plus 1 plus 1/2 theta. This means 1/2 arc tan theta. It's a theta is 1/2 arc tan x. And plus 1/2 product sine cosine. Sine is will be x over root, cosine will be 1 over root. This means x over, maybe I'll write one more time, 1 over root. Okay, I'm not copy n plus c always. I'm not copy all answer, but you can easy, this is simplified like x over 1 plus x squared. And don't forget about other part of your answer. Okay, we're solving this problem, you see. This means this method work if you don't have any roots, but you have some this kind of combination, your function and constant. Okay, doing one more example. Let's go, this will be define integral number 46. Here we have integral from 4 to 8 fraction, whereas numerical is square root x squared minus 16, denominator is x squared dx. Okay, what we have here? We have inside root we have function minus constant. If you have function minus constant, this means your substitution is secant. Because our a squared is 16, this means a will be 4. This means our substitution is x equal 4 secant theta. Okay, dx will be 4 secant theta tangent theta d theta. Now we're ready for write. Okay, how you remember? Root will be 16 secant square minus 16. It give us 16 tangent square, and take it root, it will be 4 tangent theta, divide by 16 secant square theta, multiplied by 4 secant theta, tangent theta d theta. Okay, function I'm prepared, but what about borders? I have lower border is 4. This means if x equal 4, it means secant theta equal 1. Where is secant theta equal 1? If theta is equal 0. If my upper border is 8, this means x equal 8. I plug in here. This means secant theta equal 2. Where is secant theta equal to? It's happened if theta is pi over 3. This is pi over 3. I especially show you use color what border moving for what numbers. Now I have defined integral and new border. What does mean? It means I'm not moving for my old variable when I solve. I'm counting exactly for this new border. Save time and will be more accurately. Okay, now we little bit simplify what we have. 4, 4 and 16 cancel it. Secant and secant cancel it. And here I have tangent square theta divided by secant. It's your choice how it's work. You can use substitution, you can use anything, or you can remember trigonometrical identity. Doing this way, sometimes it's interesting. Okay, 0 to pi over 3. We have tangent square divided by, okay, I write one more time. This is tangent square theta divided by secant theta d theta. Great. Integral 0 to pi over 3. I remember what is tangent is sine theta over cosine theta. But because it's square, this means square here and square there. What is secant? It's 1 over cosine. Divide by 1 over cosine, this means multiplied by cosine. Okay, d theta. Now I'm a little bit simplified. This means this cosine and this cancelled. And I have integral where is sine square over cosine. Okay. I can use some kind of rule, but here I can do it. I'm looking like easier word. I remember what is sine square. Sine square is 1 minus cosine square theta divided by cosine theta d theta. Separate for two fractions. 1 over cosine give me secant theta. Cosine square over cosine give me cosine theta. D theta from 0 to pi over 3. Okay, great. What we have here? We have two table integrals. One is give me natural log secant theta plus tangent theta. The second one give me minus sine theta. Okay, and now I need plugging 0 to pi over 3. And what happened? We need only counting. If you plug in pi over 3, you have natural log. This will be 2 plus square root of 3. If you plug 0 inside natural log, it will be minus ln 1, because secant is a sine give us minus square root of 3 half. And if you plug in 0, it will be minus 0. Okay. Remember, natural log it's 1 is 0. This means final answer is ln 2 plus square root of 3 minus square root of 3 over 2. Okay. This means if you have defined integral, you don't need go back with your old variable. Only accurately rewrite your new border and your integral. Okay. That's it for this section. Don't forget about office time and about quiz. Okay. Sorry, I try